For cos inverse x and sin inverse x, the domain is same, whereas the range for sin inverse x is minus pi by 2 to plus pi by 2, and for cos inverse x it is 0 comma pi. If we restrict the range and domain of the trigonometrical functions, then these inverse trigonometrical function will exist. The value of theta which satisfies 1 by 2 in sin is pi by 6. So therefore here theta is equal to pi by 6. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, Temple of Excellence. Today in this session I am going to take the revision of very important chapter, that is inverse trigonometric functions. So let me discuss the problems which are very important for the point of examinations in this inverse trigonometric functions. Now, before going to the exact chapter, let us know regarding the weightage for this chapter. In this chapter, you will get 1 mark 2 questions, 2 marks 2 questions, and 3 marks 1 question. So the total weightage is 9 marks from this chapter. So 1 3 marks question, 1 2 marks 2 questions, and 2 questions from 1 mark. So usually you may expect 1 question from 1 mark, and remaining 2 marks questions you may expect 2 questions from 2 marks and 1 question from 3 marks. So totally the weightage may be 8 to 9 marks. So you will get 8 to 9 marks from this chapter. Now let us come to the what is actually the meaning of inverse trigonometric function. So you might have been studied in your previous classes. So if we restrict the domain and range of the trigonometrical functions, then we are going to get the inverse trigonometric functions. Suppose if x is equal to sin theta is 1 1 and 1 2 function, then which implies theta is equal to sin inverse x is called inverse trigonometric function. So values of theta here, all the values of theta which satisfies this trigonometrical functions is called the range, whereas this is called as the domain. Now similarly we will have a inverse trigonometrical functions like cos inverse x, cos inverse, similarly tan inverse x, cot inverse x, secant inverse x, and cosecant inverse x these are the inverse trigonometrical function. So in this session we are going to study regarding the range and domain for these inverse trigonometrical functions, as well as the properties of trigonometrical functions and the problems based on this. Now if we restrict the range and domain of the trigonometrical functions, then these inverse trigonometrical function will exist. Now let us study in detail regarding the range and domain for this inverse trigonometric function. So now let us come to the first one. So function, domain, and the range here. So for sin inverse, this is very important. You may expect one mark question from this. Very important. If y is equal to sin inverse x is the inverse trigonometric function, sin inverse x, inverse of sin function, then the domain of this is a closed interval minus 1 comma 1 and the range is minus pi by 2. For inverse trigonometric function sin inverse x, the domain is minus 1 comma 1, whereas the range is minus pi by 2 to plus pi by 2. Similarly, for cos inverse x, for cosine inverse x, if y is equal to cos inverse x is the inverse trigonometric function, then the domain is same minus 1 comma 1, whereas the range is from 0 to pi. For cos inverse x and sin inverse x, the domain is same, whereas the range for sin inverse x is minus pi by 2 to plus pi by 2, and for cos inverse x it is 0 comma pi. Now for tan inverse x, the domain is r is the domain, and whereas the range is minus pi by 2 to plus pi by 2, and for cot inverse of x, the domain is same r. For tan inverse x and cot inverse x, the domain is r itself, whereas the range for tan inverse x is minus pi by 2 to plus pi by 2, and for cot inverse x it is 0 to pi. For the secant inverse x, the domain is r minus other than minus 1 comma 1, r minus of minus 1 comma 1, whereas the range is 0 comma pi minus pi by 2 other than pi by 2, 0 to pi, 0 comma pi minus pi by 2. And the last one, for cosecant inverse x, y is equal to cosecant inverse x, the domain is same r minus of minus 1 comma 1, and the range is minus pi by 2 comma pi by 2 minus 0. So these are the domain and range for the inverse trigonometrical functions sine inverse x, cos inverse x, tan inverse x, cot inverse x, secant inverse x and cosecant inverse. So, this is very important table. So, you may expect one definite question from this for 1 mark. So, in the examination they may ask, write the domain of sine inverse x. The domain of sine inverse x is -1 comma 1. If they ask to find the range is minus pi by 2 comma plus pi by 2. Similarly, for cos inverse x, the domain is -1 comma 1 and the range is 0 comma pi. And for tan inverse x, the range is R, set of real numbers, and the range is minus pi by 2 comma pi by 2. So, some range are in closed interval and some range are in a open interval. So, cot inverse x is the domain is R and the range is 0 comma pi open interval, and for secant inverse and cosecant inverse the domain is same R minus of -1 comma 1, and for the secant inverse and cosecant the range is differ. So, 0 comma pi minus pi by 2, whereas minus pi by 2 comma pi minus 0. So here the domain is same for sine inverse x and cos inverse x, and similarly for tan inverse x and cot inverse x is same, and similarly for secant inverse and cosecant inverse x we will have same, but the range will differ. So, this is how we are going to range. We will going to write the range and domain. The range is also called as the principal value branch. So, in the examination if they ask find the principal value branch, so just write down the range is also called as the principal value branch of that given inverse trigonometrical function. Now, let us move on to the problems. Now, properties of inverse trigonometrical functions. The value of sine inverse x is equal to x if x is in between -1 comma 1, and similarly the value of sine inverse of sine theta is equal to theta if theta lies between minus pi by 2 comma plus pi by 2. So, for example, sine inverse of sine 30 degree can also be written as that is equal to 30 because theta lies between 0 to 90. Now, similarly, the value of cos inverse x, cos inverse x is equal to x if x lies between x belongs to -1 comma 1, and cos inverse cos theta is equal to theta if theta lies between 0 to pi, 0 comma pi, and the value of tan inverse x is equal to x where x belongs to R. So, and tan inverse tan theta is equal to theta where theta belongs to minus pi by 2 comma plus pi by 2. These are very important properties to solve the problems. Now, let us move on to the property. This is also a property and a problem for 1 mark. So, these are all 1 mark questions. What is to prove? Cos inverse of 1 by x is equal to secant inverse of x where x greater than or equal to 1 or x is less than or equal to -1. Now, let us consider this. Let cos inverse of 1 over x is equal to theta, which implies cos theta is equal to 1 over x. Reciprocate it. Reciprocating. So, if you reciprocate this, 1 by cos theta is equal to 1 by 1 over x is x. 1 by cos theta is secant theta is equal to x. Take the inverse for this. Therefore, theta is equal to secant inverse of x. What is theta we have taken? Cos inverse of x. So, therefore, cos inverse 1 over x is equal to secant inverse x. This is how we are going to prove. Or we can also do like this. I will write here second method, or we can also do like this. Let us take let secant inverse x is equal to theta. If secant inverse x is equal to theta, which implies secant theta is equal to x. Now, reciprocate this. If you reciprocate this, reciprocating, what you will get? 1 by secant theta is equal to 1 over x. What is 1 by secant theta? Cos theta. So, cos theta is equal to 1 over x, which implies theta is equal to cos inverse of 1 over x. So, therefore, what is theta we have taken? Secant inverse x. Secant inverse of x is also equal to cos inverse of 1 over x. This is very important property. So, secant inverse x can also be converted into cos inverse 1 over x. Similarly, cosecant inverse x can also be written as sine inverse of 1 over x, and cot inverse x is also equal to tan inverse 1 over x. These are the properties. Now, move on to the problems. 1 mark problem. These are very important type of problem for 1 marks. Find the principal value of cosecant inverse 2. Now, before going to the problem, Let us know the trigonometrical ratios of standard angle from 0 to 90. Now, here let me write the table: 0 degrees, 30 degrees, 45 degrees, 60 degrees, then 90 degrees. Okay, the trigonometrical ratios are, let me write, sine, cos and tan, right? So this is nothing but pi by 6 radians, this is pi by 4 radians, this is pi by 3 radians, this is pi by 2 radians. Now, what is sine 0? Sine 0, 0, sine 30, 1 by 2, sine 45, 1 by 2, sine 60, root 3 by 2, sine 90 is 1. If you reverse this, you will get cos. So, this is 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. Just if you know one line, sine 0, 0, sine 30 half, sine 45 1 by 2, sine 60 root 3 by 2, sine 90 is 1. And for cos, just reverse, 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. For tan, divide it. If you divide sine by cos, you will get tan. 0 by 1 is 0, tan 0, 0. 2 gets cancelled, tan 30 is 1 by root 3, 1 by root 2, 1 by root 2 gets cancelled, tan 45 is 1, 2 gets cancelled, root 3 by 1 is root 3, 1 by 0 is equal to infinite. So, if you reciprocate tan, you will get cot. If you reciprocate cos, you will get secant. If you reciprocate sine, you will get cosecant. Now, let us come to the first example. What is the first example? Given, find the principal value of cosecant inverse 2. So, we know the formula for cosecant inverse x is also equal to sine inverse 1 by x. So, therefore, this cosecant inverse 2 can also be written as sine inverse 1 by 2. So, therefore, the value of theta which satisfies sine inverse 1 by 2 is 30 degrees, that is equal to pi by 6, that is it. Here theta is equal to pi by 6, which lies between minus pi by 2 and plus pi by 2. Now, or if you want, you can also solve like this, or let cosecant inverse 2 is equal to theta, which implies cosecant theta is equal to 2. Reciprocate it, this is sin theta is equal to 1 by 2. The value of theta which satisfies 1 by 2 in sin is pi by 6. So, therefore, here theta is equal to pi by 6, which is the principal value which lies between the given range. That is it. Theta is equal to pi by 6. Any method we can follow. This is one mark question. Now, let us move on to this problem. Similarly, in this case, secant inverse 2 by root 3 can also be written as reciprocated cos inverse root 3 by 2. So, the value of theta which satisfies cos inverse root 3 by 2 is, here theta is equal to 30 degrees, that is equal to pi by 6 degrees, pi by 6, that is 30 degree. Cos inverse root 3 by 2 is equal to 30 degrees, that is equal to pi by 6, that is it. Okay. Now, move on to the next problem. Find the principal value of sine inverse of minus 1 by 2. Here also it is, let us consider theta is equal to sine inverse minus 1 by 2, then sine theta is equal to minus 1 by 2. So, the value of theta which satisfies sine theta is equal to 1 by 2 from the table is, that is nothing but pi by 6. Since it is negative, therefore, theta is equal to minus pi by 6. Now, if you come to this, this is very important. Secant inverse of 2. Secant inverse of 2 can also be written as cos inverse 1 by 2. Therefore, theta is equal to, the value of theta which satisfies 1 by 2 in cos is pi by 3, that is equal to 60 degree. Pi by 3, 60 degrees. That is it. Now, suppose if it is like this, secant inverse minus 2, this is very important. So, this can also be written as cos inverse minus 1 by 2. So, here since as we studied from the domain and range, the value of theta, if theta is positive in cos, then the value, if x is positive, if x is positive, the value of theta is positive, lies from 0 to 90. If x is negative, the value of theta is positive and lies from 90 to 180. Since this is also equal to, we know one formula, cos inverse of minus x is also equal to pi minus cos inverse x. So, therefore, this can be written as pi minus this particular angle, pi by 3. So, this is equal to 2 pi by 3. Very important problem for examination. So, if secant inverse is plus 2, secant inverse plus 2 is pi by 3. If secant inverse minus 2 is pi minus pi by 3 is 2 pi by 3. So, this is less than 90 and this is greater than 90, which lies up to 180 degrees, 0 to 180, that is 0 to 90 and 90 to 180. Now, move on to the next problem. This is 2 marker question, very important for the point of examination. Find the value of cos inverse 1 by 2 plus 2 sin inverse 1 by 2. So, the given equation can be written as, so cos inverse 1 by 2, cos inverse 1 by 2. So, what is the value of cos inverse 1 by 2? Pi by 3, this is pi by 3 plus 2 into, what is sin inverse 1 by 3? Sin 30, 30 is nothing but pi by 6. So, since if you want you can write sin 30 is equal to 1 by 2 and similarly cos 60 is equal to 1 by 2. So, this is nothing but pi by 3 plus 2 3s gets cancelled, pi by 3 plus pi by 3 is 2 pi by 3. So, the simplified answer for this is 2 pi by 3, very important problem. So, just put cos inverse 1 by 2 is pi by 3 plus 2 into sin inverse 1 by 3 is pi by 6. So, this is also equal to pi by 3 plus pi by 3. Or if you want in terms of degrees, you can also write like this. Cos inverse of 1 by 2 is 60 degrees plus 2 into sin inverse of 1 by 2 is 30 degrees, 60 plus 60, that is equal to 120 degree. 120 degree in terms of radians is equal to 2 pi by 3 radians, that is it. Okay, this is how you can also verify. Now, move on to the next problem. Tan inverse 1 plus cot inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. Okay. Now, this can be solved using 2 methods. Let me explain the first method. Given equation, this can be written as tan inverse of 1. Tan inverse of 1 is pi by 4 plus we know there is one property, since sin inverse of x plus cos inverse of x is always equal to pi by 2. So, this can be written as, that is sin inverse of minus 1 by 2 plus cos inverse of minus 1 by 2 is equal to pi by 2. So, this is equal to pi by 2. So, pi by 4 plus pi by 2, 45 plus 90. So, this can also be written as, take LCM, 4 is LCM, 4 gets cancelled, pi, divide 4 by 2, 2 times it gets cancelled, 2 pi. So, 2 pi plus pi is 3 pi by 4, 135 degree. Pi by 4 is 45 into 3 is 135 degrees. Or this can also be solved like this, or tan inverse of 1 is equal to pi by 4 plus cos inverse of minus 1 by 2. What is the value of cos 1 by 2? Cos 1 by 2 is pi by 3. Since it is minus, we can write pi minus pi by 3. And for sin inverse of 1 by 2, sin 30 is off, this is negative, we can write minus pi by 6. So, pi by 4, 3 pi minus pi is 2 pi by 3 minus pi by 6. This pi by 4 as it is, plus take LCM. For 3 and 6 LCM, just take the LCM. So, what is the LCM? 6 is the LCM here. So, 2 2s are 4 pi, 6 gets cancelled, pi, this is equal to pi by 4 plus 3 pi divided by 6. Again for 6, 4 and 6 take LCM, or you can divide it. This is pi by 4 plus pi by 2. Now, take LCM. What is the LCM between these two? 4 is the LCM, pi plus 2 pi, this is equal to 3 pi by 4, that is it. So, the simplified answer is 3. You can solve like this or this, any method you can follow. This is by direct property method, this is by putting the trigonometrical ratios. Sorry, this is by substituting the values of standard angles, that is it. Okay. Now, move on to the next problem. Find the value of tan inverse root 3. So, what is the value of tan root 3? Tan inverse root 3, and just keep this as it is, tan inverse root 3 minus, this can also be written as cos inverse minus 1 by 2. So, the value of tan inverse root 3. What is tan inverse root 3? So, tan of 60 degrees. tan 60 is equal to root 3. So, this can be written as 60 degree is nothing but pi by 3 minus cos inverse 1 by 2. So, what is cos 60? Cos 60 is equal to 1 by 2. Since this is negative, we can write pi minus pi by 3. So, this is equal to pi by 3. Take LCM, 3 pi minus pi is 2 pi by 3. Again, 3 is the LCM, pi minus 2 pi, this is equal to minus pi by 3 is the simplified answer. That's it. So, the simplified answer is minus pi by 3. Now, let us come to the next problem. Same, find the value of tan inverse of 2 cos 2 times sin inverse 1 by 2. So, the given equation can be written as tan inverse 2 cos 2 into what is sin inverse 1 by 2? 30 degrees, sin 30 degrees, that is nothing but 30 degrees. So, this can be written as tan inverse 2 cos 30 into 2 is 60 degrees. So, this is tan inverse of 2 into what is cos 60? Sin 60 root 3 by 2, cos 60 1 by 2. This 2 and 2 gets cancelled. Tan inverse of 1, tan inverse of 1 is equal to pi by 4. That's it. See, tan inverse 2 cos as it is 2 into sin inverse 1 by 2 is 30, sin 30 is 1 by 2, 30 into 2 is 60, 2 times cos 60 is again 1 by 2, 2 and 2 gets cancelled, tan inverse of 1 is equal to pi by 4. Now, let us move on to the next problem. Find the value of sine of, this is also same as that of the given problem, given equation, sine of pi by 3 minus, simplify this. What is a sine inverse of minus 1 by 2? Sine inverse of minus 1 by 2. Since sine 30 that is nothing but pi by 6 is equal to 1 by 2. This can also be written as minus pi by 6. So, this is minus pi by 6. This is equal to sine of pi by 3 minus into minus plus pi by 6. That's equal to pi by 3. What is pi by 3? Pi by 3 is nothing but 60 degrees. What is pi by 6? 30 degrees. That is nothing but 90 degrees. So, we can straight away write pi by 2. What is sine 90? Sine 0, 0. Sine 90 is 1. That's it. Okay. The simplified answer is 1. Now, move on to the next problem. Find the value of sine inverse of sine 2 pi by 3. Now, let us convert this sine 2 pi by 3. What is pi by 3? 60 into 2 is 120. So, convert sine 120 to less than 90. Now, this 2 pi by 3 can also be written as pi minus pi by 3. That is 180 minus 120 degree can be written as 180 minus 60. So, see here, take LCM, 3 is LCM, 3 pi minus pi. That's equal to 2 pi by 3 you will get. So, this can be written as given equation sine inverse of sine 2 pi by 3 can also be written as pi minus pi by 3. Now, this is nothing but sine inverse of, what is sine 180 minus theta? Sine 180 minus theta. See here, you know the trigonometrical ratios of straight angles, that is sine conventions. 360 ASTC. So, 180 minus theta comes in second quadrant. In second quadrant, sine is positive. So, sine 180 minus theta is equal to sine theta, sine pi by 3. So, sine inverse of sine inverse sine theta is equal to theta. So, sine inverse sine pi by 3 is also equal to pi by 3. That's it. Okay. Now, let us move on to the next problem. Same, tan inverse of tan 3 pi by 4. Now, convert this 3 pi by 4. 3 pi by 4 is equal to 3 pi by 4. Pi by 4 is 45. 45 into 3 is 135. 135 can be written as 90 plus pi by 4. So, 3 pi by 4 can be written as pi by 2 plus pi by 4. See, take LCM. 4 is the LCM. 2 pi plus pi. This is equal to 3 pi by 4 you will get. What is this equal to? So, therefore, this can be written as tan inverse of tan 3 pi by 4. 3 pi by 4 can also be written as pi by 2 plus pi by 4. So, this is tan inverse of tan 90 plus theta is cot theta. So, this is cot pi by 4. Convert cot to tan, that is it. So, this is tan inverse of tan of pi by 4 can also be written as pi by 4 90 minus theta. Tan 90 minus theta is cot theta. So then this tan inverse gets cancelled. Pi by 2 minus pi by 4. Take LCM. 4 is the LCM. So this is nothing but 2 pi minus pi, that's equal to pi by 4. That's it. This is how we can solve in the other method. Let us move on to this problem. What is to prove? Prove that sin inverse x plus cos inverse of x is equal to pi by 2, where x belongs to minus 1 comma 1 closed interval. These are all properties. Sin inverse x plus cos inverse x is pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. Similarly, secant inverse x plus cosecant inverse x is also pi by 2. You might have been studying. Now, let us take sin inverse and convert to cot. That's it. Let us take, let sin inverse of x is equal to theta, which implies sin theta is equal to x. Now, convert this sin theta to cos. Sin theta can also be written as cos 90 minus theta. See, cos 90 minus theta, since cos 90 minus theta is equal to sin theta. 90 can be written as pi by 2. Cos pi by 2 minus x is sin theta. Therefore, what is cos inverse x from this? Cos inverse of x is equal to pi by 2 minus theta. Now take LHS. What is LHS? LHS is sin inverse of x plus cos inverse of x. What is sin inverse x? Theta. What is cos inverse x? Pi by 2 minus theta. Minus theta plus theta gets cancelled. Pi by 2, that's equal to RHS. What do you say? So therefore, we can say sin inverse of x plus cos inverse of x is equal to pi by 2, where x belongs to minus 1 comma plus 1. Similarly, we will have this. Similarly, secant inverse x plus cosecant inverse x is also equal to pi by 2, and tan inverse of x plus cot inverse of x is also equal to pi by 2. Now, based on this, let us take a problem based on the properties. Move on to this problem. Find the value of cos of secant inverse x plus cosecant inverse x, where mod x is greater than or equal to 1. Since we know this, what is secant inverse x plus cosecant inverse x? This is always equal to pi by 2. Secant inverse x plus cosecant inverse x is pi by 2. The given equation is cos of secant inverse x plus cosecant inverse x is pi by 2. Cos 90. What is cos 90? Sin 0. Sin 90. Sin 90 is 1. Cos 90 is equal to 0. So this is equal to 0. So you may expect this for 1 mark. Now move on to the last problem. If sin inverse 1 by 5 plus cos inverse of x is equal to 1, find x. So this is also, here x is to be determined. What is the value of x is to be determined. So what is given? Given equation is sin inverse 1 by 5 plus cos inverse of x is equal to 1. Transfer this sin to the right hand side. Sin inverse 1 by 5 plus cos inverse of x is equal to sin inverse 1. So sin inverse 1 by 5 plus cos inverse of x is equal to, what is sin inverse of 1? 90 degrees, pi by 2. So if you compare, this is of the form, since sin inverse x plus cos inverse of x is equal to pi by 2, therefore the value of x is equal to 1 by 5. That's it. This is how we are going to solve. Okay, hope you followed this. So just substitute sin inverse x plus cos inverse x is equal to pi by 2. Sin inverse x plus cos inverse x is pi by 2 if and only if x is equal to 1 by 5. This is how we are going to solve. So this is also, you may expect this for 1 or 2 marks. That's it. So these are few problems for 1 and 2 marks questions. That's all regarding today's session. Let us meet with the 3 mark questions in the next session. Thank you. Thank you very much.